All right, welcome everyone to today's class. It's another interesting day where we will dive into another important concept. With we are we are already in a very long way in the training program, almost ending, and things starts getting deep, starts getting advanced. But we will try and see how we can simplify that in the way we can, in the possible way we can. We grow from there. Okay, so welcome once again. Today we will be discussing on unsupervised learning. Last class we did dive into some algorithms and methods in supervised learning, and we saw how how it is being used, and its real life applications. Okay, so today we'll be looking at unsupervised learning. We have a lot into that where we will get to see clustering and association rule. You get to see k-means and a whole lot of it. So I have this document with me here where I'll be using for class today. Of course, I will drop it after class. And then again, like I always do, I will first of all start with a very real life scenario just to make you relate the technicality of what we are doing to real life. So from there, I think it will make more sense from this. Okay, some reactions that I'm audible enough and we are good to go. Some reactions, please.
You are audible.
Okay, all right. Okay, so before I even get to the content of the documents, let me try to first get a scenario, give out some real life applications or how it is used before we get to see the wordings. All right, so let me connect you to what we did last week on supervised learning. And we saw that in supervised learning, there are some things that can differentiate it between unsupervised learning. Example of it is having a feature that is an input and also having a label. And of course, now that the label is an output. So I relate it to a student who is studying for an examination using past questions that has both the questions and the answers. Okay, so that way he or she already knows the input and the outputs, which is the input and the label, which is the results or the output. So that way it will help the students prepare for future coming exams in the sense that it is the same curriculum and it can relate that to it. But in unsupervised learning, we there is no output. This is where an input is being passed into the machine model, and it is now left for the machine to uncover some hidden structures to find a way around itself and produce the label, which is the result. So if that makes sense to you, let's see how it is used first before I get to its examples. But in all, let's see, because the content here is what we cover all. So it's considered this document provides a comprehensive exploration of unsupervised learning method, contrasting them with other machine learning paradigms, and delving into specific clustering, dimensionality that I've been talking about. You see it today, dimensionality reduction techniques. So we examine the core concept of clustering versus association rule mining. You see how the both are used, its differences and its applications, and then explore common algorithms like k-means, hierarchical clustering, and principal components and analysis, which are the method used in clustering and association. All right, association rule mining. So finally, we illustrate the practical applications of machine learning. across domains. So that is what you'll be looking at, and it's actually much. So let's get started with that quick. So clustering now, where in as opposed to supervised learning, where we have classification and regression. I don't know if you still remember. In classification, where it's group things, it's categorized things into groups, and regressions, where we get to do with the numerical applications and all of that. So clustering, let me put it in a very layman terms, is the process of grouping a set of objects in such a way that objects in the same group, which can be called clusters, just try and imagine it, are more similar to each other than objects in another group, which is cluster for that other group. So it's primarily used for finding natural grouping patterns in data. Now, see the goal. The goal for this cluster is to group data points into clusters based on similarities. Let me break it down. Now, in a layman terms, you could imagine maybe an organization or a group. Just imagine organizing a group of people based on, okay, um their dressing, let me use dressing, based on their clothing preference without even knowing beforehand. Or you could group people, maybe say let's get to maybe a supermarket or e-commerce sector, where you group customers based on what they buy, based on what they used to buy, based on, okay, these customers used to buy this, based on their behaviors, this group of customers used to behave this, and based on their attitudes. So that is what clustering means. So this customer is similar. This customer, we know that this group of customer are, they must really bargain before they buy. And this group of customer, they will just see the price, and without much stress, they will just buy and leave. So that way it will help you discover market trends, and then again also help you create a tailor-made customers should I say attention. Okay, that when you see this particular command, you must ready to talk, you must ready to bargain. So it's gives made a tailor-made response or tailor-made services to the customer. So in general, that is what clustering means. So let's get to see how it is right. So a group for clustering, the goal of clustering is to group similar data points. I mentioned that together into clusters, right? So data points within the same clusters are more similar to each other than those to other clusters. So similarity is typically defined using distance metrics. Just leave this one and take the real life example I gave to you, which makes sense. Now, clustering is used for tasks like customer segmentation. I've just mentioned that, where you group customers based on their behaviors, based on their attitude, based on what they prefer to buy. Now, this is also used and in how should I say, in our browsers or in our socials, where you get to, let's say you open Netflix now, and Netflix algorithm has already seen that once you come, you already watch, you like watching business movies. So each time you visit Netflix, they will recommend more business movies to you. That means they've grouped you to that, and some other customers that patronizes business movies. So some group you watch educational products, educational clips. So they just group them. So that is the algorithm they use. So clustering is used for tasks like customer segmentation, anomaly detection. For this anomaly detection is usually used in let's say, let me make a very real picture now. Yeah, let's take airports for instance, where the algorithm is set based on people move, some based on people move. So it could be suspicious, and it will detect, for this set of people, the way they are moving is so suspicious. Let's wait them somewhere so that we check. And these other people, they are good to go. Okay, so this anomaly detection is also used maybe in a bank. Yeah, banking sector use that where they've seen that, oh, Urabong, her daily expenses is always 5,000 naira in a day. She does not spend more than 5,000. But all of a sudden, they see me withdraw 500 million at a time. It will, how should I say, spark curiosity and will like, this shouldn't be Urabong. Maybe she misplaced her card and people get to, and someone gets to have the card and make this transaction. So it can put the card on PNG, post no debit, till maybe I get to go and sort out with them. Oh, it was me. I had a serious need I needed to attend to. Or no, it was not me. Someone picked my card and all of that. Another thing is image segmentation. So these are just the applications of clustering, and they use what they use k-means algorithm, or is it they use k-means algorithm and get to do all of this. Okay, so example of this is that imagine you have a data set of customer purchase history, just what I said. So clustering could be used to group the customer with similar buying habits. One customer might represent high value customer who frequently purchase expensive items, while other might represent budget conscious customer who primarily buy discounted products. Okay, so this was that these particular customers, they normally patronizes us when we are running on a promo. So when it's promo time, sharp, all of them you see them there. But these customers are out on the other group or the other clusters of customer are high value, in that they don't really care. They just buy when needs arises. Okay, so that is that. You could also, let me just give another scenario. Another scenario just enters my head now. So you could check an online retailer. You've been ordering from all these online platform. So you could see the online retailers which clusters customers based on their purchasing behavior. Another one is that, okay, so this one they frequently buy, maybe in a week they'll buy up to 4 times in a week, and others is just maybe once, just once need arise, you just order. But there are those who order frequently. Okay, so that is that. Is there anything we've not discussed under um, clusters? I don't think so. Okay, so now let's move to association rule. I'll first of all give you my explanation before we get to the definition. Now for the association rule, you can call it association or association rule learning. So this one identifies relationship based on dependencies. That is, how should I say, between variables in large data sets. So what this means is that, yeah, a very good examples of this association rule mining is that if someone's buy butter and bread, there's every tendency that the person will buy butter, right? And if someone buys food or soup rather, there's a very tendency that the person will buy Gary or swallow that complements that. So that is just, how should I say, or if someone's buy phone, okay, there's a very tendency that the person will buy SIM card. Okay, so that is how should I say, in layman terms, I should use. So this pattern helps retailers replace related items close together. So let's say in the sections of where you have bread, you should see butter, you should see items for tea. These are related. Okay. Okay, now so that is example I could give. Let's check out the definition. So association rule, are we still together? I hope I'm not talking to myself. All right, all right. Where are we? Where? I just okay. So association rule mining, on the other hand, aims to discover relationship, just like I just said, bread and butter, or association between different items or variables within a data set. So it identifies rule that describe how often items occur together. So the most common application is market analysis. Okay, let's say consider market transaction data. Association rule mining might reveal customers who buy bread buys butter or tends to buy milk. This rule could be expressed as bread, butter, and all of that. So that really makes sense. So what it does is that it helps support confidence and lifts quantifying strength. So it's just for you to group. Yes, there's no how someone will buy trouser and will not buy polo. I'm here to complement that. There's no how someone will buy brush and will not buy toothpaste. Yeah, so I think that makes sense now. And there's no how someone will, how should I say, will buy wick and will not buy wick oil. So I think that makes sense. That's real now. Okay, now so let's check the clustering. It groups similar data points together into clusters. And association, it's the server relationship between items. So this one has two similarities, clusters of data points based on, just leave this, an association rule based on e-commerce, or sorry, based on co-occurrence frequency. This really happened. Example is the market basket analysis that I've mentioned. And for clustering is for segmentation, anomaly detection that I mentioned, and all of that. So let's see, before we even get to K-means clustering, let's look at dimension reduction. Let's look at dimension reduction before we get there. So for dimension reduction, sorry, I did not put it here. I don't know. Maybe it's not here. Sorry about that. But I'll tell you. Don't worry. Don't still lose. So how should I even put this one? Now, before I even get to somehow, before the definition is to come, let me set this analogy. Now, imagine you have a receipt book with maybe say 100 different ingredients, right? Now, let me use a very typical scenario. Let me use a very typical scenario. Imagine you want to cook rice. There are some key ingredients that you shouldn't miss, which includes, you don't need to miss crayfish, you don't need to miss salt, you don't need to miss maggi, and all other necessary items. But look at in the case that maybe you just want to add extra things which are not really important, which is with or without, you still have your food cooked, which includes maybe you want to put different varieties of meat. You want, okay, in that rice, let me have pork meat, goat meat, which is not even necessary. With or without, you can do without it. You can still cook. And another thing is, how should I say? How should I say? When it gets to my head, but okay, let me pick out a very select something now. Let's say you have 100. Let me see, use that book now. 100 different ingredients, but realize that in this particular dishes, only few would have few core for ingredients. So what dimension reduction helps you do that? It helps you narrows down to the core or the most important ingredients, which makes the process faster. Okay, now this is what image reduction uses. You get the, so let me kind of give you the definition now. So dimension reduction reduces the number of input variable in a data set. Yes, a very clear example is that the other time I said example about getting house. So the color of the house or the paint does not really, although somehow you need it, but you can do without it. So irrespective of the color of paint, it shouldn't add to the price. That just came to my mind and I had to tell you. All right, so dimension reduction reduces the number of input variables in a data set while retaining as much important information as possible. Those are the things that are important. You can't do without. It is like a core. Okay, like these are the core things you cannot do without. So what it helps does is that it helps simplify the data set, improve and possibly improve performance, and then again make the process fast. That means it increases the speed of that process. Okay, now a very technical example of it is that in facial recognition, all these technologies that uses facial recognition. let's say a picture, right? Now, let me take a picture for example. A picture might have thousands of pixels of features. Okay. So what it does that it can reduce the dimensionality of those things and stream it to the most important things that could make you identify a person, which includes the person eye, and the person nose, the shape of the mouth, and others. Okay, so those are the essentials for identifying face. So in this case, let's say you design a model for that, it will make that model very fast and efficient, right? Okay, still under, have I talked about anomaly detection? Okay, before we get to this K-means, because this method we used to achieve that. Now, for the anomaly detection, how should I say, beautiful. Now, let's say it's in an email spamming, you could have a model that does that checks for spammy or somehow malicious email. Okay, so what this does is that it helps prevent it before it even gets to the user's inbox. That is one. Another two scenario I could mention to you that, okay, I've already mentioned about the airport security system, which looks for suspicious behavior. So while other travelers pass through security without any issues, all right. So the system maybe it could be designed to detect individual with some suspicious move, or which exhibit some suspicious action. So those are called anomalies. So with that, they can just wait them somewhere and pass a check to them. Another is in the banking sector, mentioned that where anomaly detection is used to detect fraudulent credit card transaction. So what the model does is that it flags transaction that deviates from the normal or the usual customers and spending pattern. Okay, someone who's paying 2,000 naira in a day, all of a sudden we see 100 millions. It flags as somehow potential fraudulent and all of that. Okay, so that is that for that. So let's see some of the algorithm that helps us achieve this, which is um which is scheming. We have scheming, we have hierarchy and clusters and so on and so forth. Now for the k-mean, where okay, now for the k-mean, it falls under, how should I say, clusters. So it falls under partitioning clustering method. Like it's clusters similar things in one place. So where the data set is divided into patterns or partitions or to form clusters. All right, so K-means is a centroid-based clustering algorithms that aims to partition a data set points into K. Now, in this K, you could check it as your hyperparameters. I talk about hyperparameters that day, which are the things, hyperparameters are the things not in your data set, but the things you put in place to make sure that your model does not overfit and does not underfit, but will just learn better. So I don't know if you still remember that. Not if not, watch recordings. Now let me break down this K-means clustering. All right. So K-means clustering, let's say, is an unsupervised machine learning algorithm used to group data sets into K. I'll still use that K into K distinct, if not K distinct or non-overlapping clusters. It just will in their own distinct partition. It does not overlap. That is what it means. So it does not overlaps with other different clusters, and it is widely used in um for what I've mentioned already. I told you the algorithm using that for image compression, anomaly detection, and all of that. Okay, so let's see the process. So it's randomly selects k initial centroid. Now, what this, don't let this k confuse you, because this k is a constant, which is it is usually known before you even start. Let's say you want to group put two things. Maybe you want to group things into two clusters. So the two here is the K. So it is known beforehand that it is two clusters you need. If it is three, you know that it is three clusters you need and all of that. So the case shouldn't confuse you. So each assigns data points to the nearest centroid based on distance metrics, which is the Euclidean distance. You can leave the technicalities or look at the data. So another is to recalculate the centroid of each clusters by taking the mean of the data points assigned to the clusters. So let's look at it. So repeat these steps 2 to 3 until the centroids no longer change significantly. So what this means is that it just found two similar groups. So irrespective of the numbers of iterations that it repeats, that the cycle runs, it cannot go beyond two. Just see two groups of people with people who are like-minded and maybe people who are not like-minded. So it's no matter how it runs. So that is what this means. Okay, so let's look at it. This is just a cycle. Initialize centros, assign data points, update it. If this update comes, is that if it sees anything different outside from what was already assigned, so it just updates it and the iteration continues and all of that. Okay, so example of this, let's see. Suppose we have a data set of customer spending habits, okay? Amount spent on groceries and amount spent on entertainment. Okay, so this, we want to segment these customers into three groups. This way, you see that the K now is what? 3. So K means we iteratively assign customers to the nearest central to just position them to their similar groups or clusters. So we calculate the centers based on this and repeat the entire assignment. Okay, so you can just check that out. It's nothing much, but it's just what we've talked about. But understands that it's partitions similar items into clusters, and that cluster should be known. If K is 3, you know that we have 3 clusters. If it's 2, you have 2 clusters. So you can either check. So advantage of the K means is that it's simple and easy to implement, and it's relatively efficient for large data sets. Okay, the disadvantage of that is that it's should I say it's sensitive. It's very sensitive to change. Let's say as it's in the cycle of iteration, it could discover something else that is maybe even one out of the 3. It will still check it out. And you know its applications is used in image compression, anomaly detections, and all of that. Okay, so let's share for hierarchy clusters. So hierarchy clusters build hierarchy clustering rather builds hierarchy of clusters either to the bottom top extreme, which is called agglomerative, okay, or to top down, which is divisive. So it's either the two. Now, what this does is that it works in hierarchy. So let's say you get to a firm, you should see the top people who manage the company and just from maybe some of the incentive tax staff rather. So that is what it means there. Okay, so for this, each data point starts at its own clusters, very extreme, very extreme. The margin is very large. You could look at the GM of any firm and just any other incentive staff. The margin is always very large. My merging. So it should iteratively merge the two clusters. The two closest clusters based on what their linkage, what how should I say, to their closest or similar. Yeah, let me use that word, similar pattern or based on some criterion like that. Okay, so this you can check out, but I believe the explanations does better. This still falls under the hierarchy, but it's just another form. Hope I'm not talking to myself. Okay. I just because when I leave. Usually when I leave the site, I don't really get to see what is going on there. All right, so now another important thing is the principal component analysis. All right, so this one could help in noise reduction, in a noise reduction, should I say a platform or software where it takes only the concentrated voice, just like what I'm doing now, and any background noise or device noise, it's just discard it. So principal component analysis, let's check its wording. So PCA for short is a dimensionality reduction. Of course, you know what dimensionality reduction means, that it takes out all other unimportant or features that are not really necessary and streamline it to the core. All right, so that is why it's based applies in a maybe noise filter or noise reduction software. So that is what they use. They just take out the, how should I say, the standard or the main voice, then what comes like background or any other distractive noise, it just reverse and reduce it to the main voice, like the components one. Okay, so this is a dimensionality reduction techniques that transform a set of correlated variables into a set of uncorrelated variables. So this might sound somehow strange or difficult to get, but the analogy I gave should help this make sense to you. So the principal components are ordered. Those are the core things, are ordered by the amount of variance. All right, they explain in the data set. Okay, so standardized variance, these are just some of its applications and the steps. Okay, so let's look at the applications of unsupervised. Now let's make a clear distinction between the two. If, for instance, in the supervised machine learning models, the input is given and the output is given, that means you already know forehand. So the question is, why then is the need for unsupervised learning? Now you should know that it is not always the case that at every given input you also know the output. So for instance, now let me still use an e-commerce analogy, fame as an analogy. What is those that you don't know if this someone walking in, what the person will buy, but unsupervised learning, based on how it groups based on how it groups using clustering now, through the model, it groups this customer that they don't really buy. These are not just come and go customers that will just come and check what you have and go, but this one they come, they sit and buy. So next times the model sees customer who was in partitions in that cluster, the model will automatically realize that this one cannot go without buying, it's you. So that is just a clear differences between one, you know, the input and the output. The other is only the input is given, and the model will now devise a means to see to get the label or the output. All right, so applications of unsupervised learning. Without misstating, I've mentioned a lot of them, so you should know. But let's see again. Customer segmentation. So it groups customers based on their demographics, purchase history, and what behaviors. And now another one is anomaly detections, where it detects or what should I say, suspicious move, or it detects um any anomalies, right? So this one, it's identify unusual or suspicious data points that deviate from the norm, from how it is. I've said an instances is used in the banking sector. It's used that's the security system at the airports use, and all others applications. So image segmentation, partitioning an image into multiple regions based on their pixel. So it could streamline the core to words to some features, like, so this one use words a dimensionality reduction, of course. So document clustering, yeah, yeah. I forgot this to mention this. There's a very clear example of it, where you go to, maybe you go to a particular site, maybe a blog, and each time you visit there, you always read book of a particular niche. Maybe you always read books in about tech, all right. So the next time your history has been saved. So the next time you go to the site, it will suggest tech related documents or materials or resources for you to read. So this is what this means. So another is recommendation system, all right? So recommending items to users based on their past behaviors, based on their past behavior and the behavior of similar users. I just mentioned that they've been seeing you do this, or maybe, yeah, another thing is that maybe you go to a eateries, a particular eateries, and once you go there, you like eating jollof rice. So the next time you go there, the waitress will you want to you've come, I believe it's the love rice you want to eat again today. So this is based on your past behavior and what you've been patronizing. So fraud detection, I've mentioned this. Another is bioinformatics, analyzing gene expression data by identifying patterns and relationship. This falls under what's now clusters. Okay, so that is just that. Okay, let's see. I have a good example, and let's hit. Okay, so before I even get to see the coding example, is there any questions to that? Any questions? Are we good to go? I should proceed. Hope you did not lost me. Can you hear me? Uh-uh. Hope I wasn't talking to
We are
my.
hearing you.
All right, all right. Okay, so usually when we get to type it one by one, it gives us error. So like the last, I have a good example, but I'll just explain it line by line. I'll take my time to really explain that. And this one I decided to use the k-means. It's just a very simple explanation what we've been doing, but I'll try my best. Okay, so this part is where I import my necessary libraries that I use. So for this one, this is where I import pandas for data manipulations. Because you know what pandas is for data manipulations or what and efficiency. So this will be used to grade data frames, if you already know. And matplotlib, we need it to visualize our data. So matplotlib is for data visualization. And now this came in this one, so is where I import the k-means itself, the k-mean algorithm for what, for clustering. All right, so this is just a simple data set with which we want to cluster. Okay, let's get it. So this is just a simple Python dictionary of key and their values, so with their key value page. So this spending scores is just a measure of how much a customer spend. its price, and this is their related age. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it matches. So it's just a measure of how much a customer spend and with their different age. So I use the pandas library to convert this into a pandas data frame. At this point, this is that actually I say Python, so I convert it into pandas data frame there. Okay, so now this is where the crux of the matter is. So now this k-means is a variable that I give. Now I create a k-mean model here that will cluster. What's the problem? That will cluster. I just lost that. Okay, so here I get a k-mean model that will cluster these words, this data into two groups. Of course, you've seen my n clusters, and I want to cluster it into two groups. If it's 3 here, you know it's 3. But in this case, I want to ensure that it is 2. And I talk about this the last class. So this one now ensures that it's, how should I say, it it ensures reproducibility. So each time I run it, it still gets to reduce the constants. And here is just for data visualization. I've done that. We've done this before. And just not I forgot this line. So this line is this algorithm learns the pattern in the data set and form clusters based on similarity. See the data frame that I call DF here. So it will learn and underscore PD. So what this does that it will learn the pattern of the algorithm in the data sets and form clusters based on what their similarities. So what it does that is you assign each data point to one of the two clusters that I said. So if it matches the first one, it's assign it to them. If it matches the second one, it assign it to them. Okay, so this one it's where I call in our maths plot slip for visualization. So it should use a scatter plot of what age and income, then make a cluster of it. So the x-axis should be the age, and the y-axis is the income, and the title of what I'm plotting is what customers plotting. So I use PLT to show a graph. All right, so is my network back now? If I run that, okay, so it's done. So you've seen the scatter plots, which takes people at the particular age range. So it says that people within the age of 25 to 35, this is their income. Their incomes falls under this range. All right. And people within the age of 40 to 45, their incomes fall under this range. So this is just a very simple illustration of what K means, using what we've been doing before, try to make it simple. And then we use the K-mean of algorithm to do what? To make a cluster of similar group. In my own case, I use the age and what's their income. So could see that people in a certain age range from 25 to 35 falls under this income range, and people in a certain age of 40 to 45 falls under this age range. Any question? Okay, so with that, you've seen how supervised learning works using clustering, and we've experimented K-means, a method used in clustering, and then again we visualize the clusters using matplotlib to see how it works. So just using a basic data manipulations pandas, you could see. So basically, it's not a rocket science. In a nutshell, this is its applications. You've seen the real life example of it. So, that is it. All right. I just hope the class is so silent. Okay, so any question from that? No. Okay, so in the absence of no question, there was just a very simple illustration. I will have to leave the document in the group. And I think our last class should be on Saturday next.